My name is Andy Murren, and I work for Deloitte & Touche in the Enterprise Risk Services, and I do a lot of work in software assurance, and I do some cloud and virtualization work. And what we're going to do today is, considering time constraints, we're going to do an overview, a rapid overview of virtualization and cloud, and then we're going to walk through a sample application. The first half of the talk will be more informational, and some of you may zone out because you already know it. Others, this is a good baseline. Just want to make sure we have a common vocabulary. And then the second half, I'll probably tell you nothing and ask you lots and lots of questions for you to take back to your organizations. So, and I also assume everybody can read while you listen to me talk, so I'm not going to read anything to you. The bottom point is one of the most critical. In cloud and in virtualization, the boundary is where? Well, we used to think of, you had a DMZ, if you had an application, you needed port 135 open for your application to work right. Well, then you would mitigate that by making sure the firewall had port 135 closed. Well, now the boundary is not the edge of your network. Now the boundary is the edge of your host, your virtual machine, your OS. So the boundary that you need to defend is much closer than what it used to be. Virtualization is not equal to cloud. Virtualization is an enabling technology. Cloud is a service delivery model. They are not the same. Virtualization enables cloud, but cloud is not dependent on virtualization. So what is virtualization? In the next couple of minutes, we're going to punch through some baseline information on virtualization and cloud like I talked about. You can virtualize a lot of things. Most of us are familiar with virtualizing your applications and your OS, your compute cycles, those kind of things, your servers. There's also storage virtualization. We see that in SANs a lot of times, where you'll have a SAN in the back end that does all your storage. In some implementations of virtualized environments, there is minimal, if any, hard disk storage on the actual physical host that's running the OS. It's all back on a virtual machine someplace. So you can bring up multiple instances of an OS or an application stack by reaching back into the SAN and pulling that onto the hardware, and it runs there mostly in memory. Storage virtualization, as I like to say, is kind of like my waistline. After 40, it has a tendency to expand and never retract. Application virtualization, when we go and we take an application, we virtualize it across a number of hosts, a number of different pieces of hardware and software. And you can do that a couple of different ways. You can do it where the application itself is virtualized and served out, and also with desktop virtualization. Citrix, I'm sure a lot of you are familiar with that, where your desktop is back in the cloud someplace, it's back in the server room, and you're out on a thin client, or you're on your laptop, your home computer, and you can reach in and get to your desktop back at the office. So the desktop virtualization is a big thing, and you're going to start seeing that on a lot of mobile devices, iPads and other tablet type of devices. There's a couple of different ways of doing virtualization. And virtualization started back in the 60s with IBM on mainframes, and it's continued through, and it's evolving. Right now, most of the CPUs from the hardware vendors support native virtualization right on the chips. You also have the older stuff where chroot on Unix boxes, and then Sun's containers and zones. Those kind of things are at the OS level. And then there's a minor but important distinction, full virtualization. That's where you're running native. The virtualization machine is running right on the bare hardware, and it completely emulates the hardware in the OS. VMware does that. The para virtualization is where most of the stuff is done, not 100%, and they use APIs to do the rest of the interfacing there. And that's what Linux and Citrix do with their Xen. And the IBM LPARS does the same sort of thing. All right, so the hypervisor is the software that interfaces between the hardware and the operating systems. And there's two types of hypervisors. There's the type 1 hypervisor, where the hypervisor runs right on bare metal. And that's something like VMware that we're used to, ESX, where you'll go in and the first thing you do when you get your hardware is you're going to go install the hypervisor on the hardware and then install OSs on top of it. A type 2 hypervisor is more like the free versions of VMware that you can run on your desktop, or the Sun VirtualBox, where you have a baseline OS, then you install the virtual machine manager on there, and then you install a guest OS. So you have a Windows laptop, you install VirtualBox, then you can install Linux and run Linux inside, but you have to start Windows first. So that concludes my very rapid discussion of virtualization. The slides will be available so that you can read them in more detail online. So cloud computing, as I said, is a service model. It has 5 essential characteristics as defined by NIST. Rapid elasticity is one of the things that's really critical to developers. And the reason is you never know when and where new systems are going to come to life. In the cloud, you don't know where your systems are. They could physically be in different countries. They don't have to be in the same server room. They don't have to be next to each other. When we go and we develop for current internal use inside of an enterprise, a lot of times it's developed and we'll set up a database cluster and everything is right there. We know we're going to have 2 SQL servers in our database cluster. They're physically next to each other. They're on the same physical switch and they talk directly to each other, and we've got a firewall in front of them and we know nobody else is talking to them except for those 2 hosts. In the cloud, you don't know that. You don't know how many SQL servers you're going to end up with. You don't know where they are. If you don't know those things, you cannot assume the network is protecting you. You can't assume that the channel back and forth between the 2 of them is secure. You have to encrypt it. You have to have the systems identify each other. So this is where PKI and a lot of encryption comes in, being important for both protecting the data in transit and identifying the systems mutually in both directions. So characteristics, these are the different service delivery models. Vendor cloud, external. This is where we go out and we get Amazon to go and host our systems for us, where we're all out on Amazon Web Service. Private cloud. A lot of organizations, in the past we've worked with organizations that had the struggle of, hey, I know, I'm doing capacity planning, and I know for the enterprise I need so many terabytes of disk, and I know I need so much bandwidth for the enterprise. And in the past, we've never really looked at it as a vertical. I'm going to launch a new application, and in order to support this application, I'm going to need X amount of bandwidth, and I'm going to need X amount of capacity and storage, and I'm going to need X amount of CPU. And we've never really looked at it in a vertical. We've always had the individual organizations responsible for storage and things handle that for us. And now the cloud allows us to work those things in a vertical much more and expand and contract as need be. And contraction being one of the interesting parts of this, we can turn off systems as quickly or almost as quickly as we can add new systems. Hybrid clouds, where you've got some stuff internal, some stuff external. You may go out to Amazon and they're going to host the front end for you, but you decide to keep all the identity management and the database, the fiscal database where you're doing your order processing in the background in your data center, not out with Amazon. So that would be a hybrid cloud. Community clouds, people sharing similar services, similar needs. So the different ways of delivering this, we got software as a service, and Salesforce.com is always used. you're out, you're using somebody else's application. What are you responsible for? Not really much. They own all of it. You're configuring and you're customizing the application that you're going to use. Your organization does not have anything to do with how that application is really configured to work. It's not worried about the OS. It's not worried about the hardware. It's not worried about the network. When you go out and you do platform as a service, you can go out to Amazon and you can stand up a system with a Linux box running MySQL, or a Windows system with Microsoft SQL Server. So you're responsible for the application and above, and Amazon is responsible for the OS and below on your stack. And the same when you go out and you do infrastructure as a service, you're basically getting the hardware level, and you are responsible for the OS and up. So there's different levels at which you need to negotiate with the cloud service provider who owns what, who's responsible for what. And the problem that you run into is where there's a gap between what they're going to do, what the provider says they're going to do, and what you say you're going to do. That gap by default is your ownership. So if somebody doesn't figure out who's patching what and something goes unpatched, by default it's your problem, not the service providers. It's very important that as you go out and you work with service providers, whether they're your internal organization or an external organization, it's important that you figure out who owns what and what you're going to do. So some of the risks that we've got. Deployment rules. Do you want your financial system in the cloud sitting next to the public relations news web server? Because you've got trust zones. Do you trust that stuff next to you? Can you trust it? And then under operations there, we've got logging and monitoring. You need to figure out as you're developing the applications the level of logging and monitoring so that you can do audit and non-repudiation and have a forensic trail back. And oh, by the way, you have to pay attention to privacy laws, because privacy laws in the EU and different parts of the world are different than they are in the US. So what you can get away with in the US, you can't get away with necessarily elsewhere. Because you've lost the perimeter, you've changed your attack surface. And the attack surface is what's exposed for the bad guys to come at. As you change that attack surface and you move into the cloud, you're changing it. It's getting bigger because your perimeter is now your host. It's not the network edge. And as you move to more and more mobile devices, it's even worse. And I've seen articles where where financial institutions, because more and more people want to do online banking from their cell phone, they're dumbing down the requirements on their passwords so people can have an easier time entering passwords on their cell phones. So we're moving back away from complex passwords with uppercase, lowercase symbols, because it's a pain in the neck to have to go and do all those extra shifts, to simpler passwords. Well, now we're adding exposure. We're making it easier for the bad guys to get into our systems. The Cloud Security Alliance has their top 7 threats. One of the biggest ones that we have to worry about as developers is insecure APIs and shared technology vulnerabilities. If you're out with Amazon or you're doing a software as a service and the vendor goes and changes databases and you've written some custom code in there and they were using SQL Server and now they're using Oracle, those SQL statements are not necessarily equal to each other. And there are times when back-end systems don't communicate as well as we would like between different vendors and sometimes even between different versions. So if you're not responsible for managing the systems, sometimes you'll run into problems as the vendors change what they're using. Threats to confidentiality. Bottom there, failure of security access rights across multiple domains. You're using different domains. By default, you have to assume you're not using a single managed enterprise system where you can talk easily and know that your stuff is secure because you're across multiple domains. And by that, stuff could be in one data center, it could be out in a different country. There's a lot of different things that come into it, and you can't always pass credentials easily. So here's some of the threats for integrity, and the first one there, incorrectly defined security parameters. Configuration management is really critical. You don't necessarily own configuration all the way down. In an enterprise, hopefully you do. But in the cloud, you may not, depending on the delivery model you're using. If you're using platform as a service, the vendor's responsible for the OS, and the vendor is responsible for the network security. You can't necessarily go out to the network vendor, the cloud vendor, and say, oh, I want you to open up port 135 for me. They can turn around and say no. Or they might have opened it up for somebody else and left you vulnerable because you were counting on that as a mitigation for your system. Availability. You are pen testing your stuff before you deploy it, right? Or you think the cloud vendor is going to be happy if you start pen testing your app once it's in his cloud? You think other customers of that cloud vendor are going to be happy with it? When you get ready to deploy, how are you going to pen test and do vulnerability assessments on your systems in an environment like the cloud environment you're going to live in? Because a test environment that doesn't replicate real world is not near as effective. Okay, so we punched through that, and now we're on to the meat of this. And now I stop telling you things and start asking you even more questions for you to consider. All of these things are relevant within your environment, for your application stacks, for your regulatory requirements. So no two answers are necessarily going to be the same. A lot of the principles are similar across the board. The Cloud Security Alliance has 13 domains right now, and domain number 10 is application security. They've got some good information on how to help secure your applications in a cloud environment. How many people have mainframes that might be still part of your enterprise, or really old applications, and old meaning more than 5 years old? All right. So Hartford, Connecticut, still home of all the insurance companies in the US. They still got mainframes running DB2, COBOL, and stuff like that, and they're trying to put some of that stuff out in the cloud. Since they had to go and bring guys out of retirement for Y2K to have 4-digit years, do you think they're really prepped for some of the threats that they're going to have now? I would venture to guess not, but your enterprise may run into the same sort of situation where you've got old applications they're pushing out. We're going to walk through a little example of an application that we're going to put in the cloud. And for our example, we're going to use a basic 5-step SDLC. Plan, design, develop, test, release. There are lots of different ones. Whatever one you want to use, go right ahead. So the Enterprise Widget Exchange, that's our sample application. It's a multi-tiered architecture, and twice a year we have surges in sales. September, right before the end of the federal fiscal year, and Christmas time. So at those times, we're expecting surges and then contractions in how much support we need for our application. We have an existing client base, and we've got clients in the US and the EU. And again, this comes into consideration when you look at privacy laws and what kind of data you can take and store. Now here's where I ask questions and don't tell you anything. When you're building these things, when you're in the planning stage, you've got to come to some decisions. And a lot of times in organizations, we kind of skip plan, leap into the second half of design and start coding. And can you really answer the questions? Because how much time do we spend as developers going back and asking, You know, I'm trying to build this house. How many stories is it going to be? What's the neighborhood? Is there sewerage, you know, or do I need to do septic? We ask a lot of questions, and a lot of times we try to retrofit things. And I know I'm preaching to the choir on that one, but we need to start asking these questions up front. What's the confidentiality, integrity, and availability sensitivity of it? If you're dealing with Department of Defense, they're going to come out and tell you the mission assurance category and things like that. If you're dealing with NSA, they're going to tell you the protection levels that you need. Within commercial vendors or for internal use, you need to figure that one out. Because the PR website doesn't need the same amount of protections, obviously, as the financial page or an e-commerce does. These are all the kind of questions you want to be asking at the design stage. Identity and access management is critical. If you're doing a hybrid or you're doing an external, a vendor-hosted private cloud, you really, really, really need to spend a lot of time figuring that one out. Because it's not just identity and access for you, it's for the clients. It's for the cloud provider. What if anything, are you going to let them do? What do they own? Who's managing the virtual machines? Who's managing the hypervisor? Who's managing the OS? Who's managing the database? And you've got to start working your segregation of duties and then having your policies and procedures in place to make sure that you're aligned with what you need to do. The policies and procedures for cloud are not equal to, they're not exactly the same as for other environments. So there's a policy and procedure and governance level that needs to be worked ahead of time. There's also the contracting piece, which we won't really get into, but you've got legal and regulatory requirements for the different jurisdictions. And if Amazon's got 3 data centers, West Coast US, East Coast US, UK. If you've got things that can't go to the EU for whatever reason, and you don't tell Amazon you can't back this up or have anything over in the UK, they may well go and shift it over there and you won't know it. So that's a consideration you need to take into account before you start. Encryption, I've touched on it a couple times. We've seen, you know, Microsoft SQL Server comes with its own little encryption thing where every time you start it up, it sets itself a new key. Well, does that really work in an environment such as the cloud where you may be bringing systems up and down throughout the day or over a period of time, and every time it starts and stops, you've got to go and manage keys again? Part of this is hands-off. So you've got to figure out how are endpoint systems, system-to-system identification and validation of who's who going to work. And it has to be 2 ways. You can't just throw it out there and say, hi, I'm Joe, and then the other server goes, oh, okay, Joe, and start processing stuff. Joe has to be authenticated, and then you have to authenticate back to Joe. Make sure the servers talk to each other and they know who it is. And how are you going to do that when, because the cloud's elastic, you go from 2 servers to 5 servers to 2 servers again? How do you know that when you lost connectivity to one of those new servers, that was intentional and not because it got knocked offline for some reason? And then your end-to-end encryption. You don't know where 2 systems are going to be. Who do you trust to look at your data? Me, I trust no one. You encrypt your stuff at home on your wireless link at home. Why wouldn't you encrypt the stuff out in the cloud when you got client data or company data on it? So that end-to-end encryption, and you need to figure out what's enough encryption for protecting your tunnel. ROT13 is an answer. It's one level of encryption you can do. It may work for what you've got. It may not. You might want AES 256 or something to go across. You might want more. Don't know. You have to figure out what the threats are, and that will help drive your decisions on the other areas. happens, what type of news groups and news feeds do developers typically read? Typically, it's going to be stuff around how to do this nifty new algorithm, what's the latest cartoon, things like that. Dilbert, well, everybody reads Dilbert, right, pretty much. But they're going to look at stuff that's applicable to what they're doing. They're going to be looking at stuff that developers are interested in. What are they not looking at? They're probably not looking at the security news feeds that tells them that that language that they're using has a new hole in it. They're probably not looking at, if they're developing in PHP, they're probably not looking at the PHP security list. Because they don't think it matters to them. They don't think there's any reason for them to care. Because security is always somebody else's problem. When we develop, and part of our policies and procedures needs to include a way of closing the loop. There's got to be a feedback loop. The security guys are out there fighting every day, trying to protect the enterprise, protect the network, protect the systems. The developers are developing software that may or may not be secure, and probably is missing all sorts of stuff. If you think about it, software is the weak link. Yes, people can go and counterfeit the Cisco switch and go put a backdoor into it. Well, that backdoor is still software. And writing poor applications and not putting adequate security into applications, that's really where everything is. That application layer is where the vast majority of our problems are. Having the developers ask and answer these questions is critical to making secure systems. Gary McGraw talks about half the flaws are design, and about half the flaws that we see are in the code itself. You got to work together with these through these stages to do this. Latency. The network is not instantaneous. It's not. It's there. You don't know how far it is. You might have two servers right next to each other and there's virtually no latency. They could be clear across the country. I know that in Wall Street on some of the applications, they don't do any encryption at all because the difference in milliseconds to encrypt and decrypt that message is potentially millions of dollars. The speed of light is not fast enough for these traders. So encrypting stuff is an issue for them. They don't want to do it. How are you going to handle latency? How are you going to handle those kind of clients coming in and saying, I can't encrypt because that would hurt me? Test-driven development. Anybody do test-driven? A few people. When I started programming ages ago with AT&T on mainframes with DB2, COBOL, that was one of the first things they taught us in the AT&T way of doing things. We started with test plans because developers are going to write what kind of test plans? They're going to write test plans and tests that prove their thing works. They're not going to go and write tests and test plans to prove that it works properly. They're not looking for failure modes, they're looking for success modes. So when you're developing your test plans, you have to take care of answering those questions. Am I failing in a safe way? Am I just blowing up? This comes back to we're not necessarily going to have the same environment. How many people have development environments and production? And nothing else in between. There are organizations where the developer's desktop is the dev environment and the hosting environment is the other environment that they have. And so stuff immediately gets promoted from the desktop into production. You can't test that way. And we've got a lot of tools, and there are going to be some talks on tools out there for static and dynamic code analysis. One of the nice things about the tool sets from Fortify and formerly Ounce was it was integrated throughout the life cycle. So the developer knew when they screwed up and they had to go back and fix something before it got into production or into the collaborative environment and got compiled with the rest of the application. So you could go through and do those things. We still need to do pen testing. And anybody familiar with Bobby tables, the XKCD, where mom, Robert, apostrophe, student database? All right. How many quality assurance people know to look for the difference between O'Connell with an apostrophe and Robert apostrophe right parens? If your QA team and your tests aren't doing those things, you're allowing SQL injects, but that's not just cloud specific. That's basic. What is different about the cloud is we used to trust the interchange of information between two systems because we figured they had a firewall and they were separated. They were in their own little trust zone, and we could trust whatever happened across the network, and we didn't have to go and check the data interchange, both going out and coming in. You want to make sure all the applications now within the cloud really need to check everything. There is no one trusted because you don't know what's between point A and point B. After you've released it into the wild and you've got it out in production, really, this is where most of the time is spent, doing maintenance on the system, making sure it continues to work. The majority of the life cycle is after release. You still need to do patches. You still need to do patch management. But you don't necessarily own the patches anymore, right? If you're doing platform as a service and the vendor owns the OS and they go and patch something and it breaks one of the things you're relying on, you've got to know about that. You've got to fix that. You've got to be able to work with the vendor. And quite honestly, the vendor is not necessarily going to be willing to leave you on NT4 for very long because they have a responsibility and an invested interest in making sure everything's patched irrespective of what your needs are. So they may or may not patch things on a timeline that you're willing to work with or you're ready to work with. So you've got to get that worked out ahead of time. Segregation of duties goes back to identity and access management. It's really critical that you have well-defined segregations of duty. And this goes back to the old, well, actually not old, but the ICBM thing where you got two keys, two people on opposite sides of the room, each with a key, so there isn't an accidental or deliberate launch of an ICBM, which would be a bad thing. PKI. In some organizations, to give you a PKI certificate, there are 12 people involved, none of which deal with each other. They are not directly, they probably know who each other are, but there's 12 people involved, each of which does one specific action and hands it off to another person which does a specific action. And that is a segregation of duties. Do you need to have that level? I don't know. But what you do need to do is make sure that you don't have the person managing the virtual machine, managing your OS, and managing your database. And the developers, and I have seen this, developers who have access to the database directly so that when there's a problem in the database, they can go fix it manually. They get to write a special SQL command and go in and fix that from $50 to $500. Oh, and yes, that's outside the audit trail, so how do you know that that's right? When I was at AT&T, we used to do fraud. It was entertaining to see what people would try to get away with, giving each other bonus points and stuff. You've got to work with those segregation of duties to not allow people to do those kind of things, and where you have to have an audit trail available within regulatory and legal requirements that you have. Key takeaways. Most of this stuff is the same. It's the same sort of stuff we're doing. I stand corrected. It's the same sort of stuff we should be doing now. Most, not everything. The biggest things are, there's no more boundary. The boundary is now the edge of your host. And there might be 15 other operating systems up there hosting 15 other different clients for the cloud provider. And you can't trust any of them, and you can't necessarily trust the cloud provider because cloud providers make configuration mistakes and have malicious people in there too. So you have to take care of yourself. By default, it's your responsibility to make sure this stuff is secure. Elasticity is in the past, we knew how many systems were going to be running. Now we don't. We can't necessarily say we're only going to have this many systems running. Now we have to understand that things come and go and we don't control them. And that is my very fast blast through a 2-hour session. I'd like to thank everyone for coming out, and I hope it was educational. And the slides will be available online.